In the early days of decentralized finance, the promise was a completely borderless digital economy. Instead, we built islands. When developers build an application on a network like Ethereum or Solana, they fall into what is known as the monolith trap. The application's logic, its user base, and its state, the current record of who owns what, are entirely confined to that specific environment. For users, this means navigating a fractured landscape. If you hold assets on one chain but want to use a lending protocol on another, you can't just interact with it. You have to manage different wallets, pay fees in different native tokens, and carefully thread your assets through a maze of disconnected infrastructure. Developers face a similar wall. Reaching a new audience on a different blockchain requires rewriting the entire application from scratch in a new programming language and managing a completely separate pool of liquidity. The industry's brute force solution to this isolation has been to construct cross-chain bridges. These are external protocols that lock up a user's native asset on one chain and mint a synthetic, wrapped version of that asset on another. We are trying to build trustless, decentralized coordination systems, but to make them communicate, we force users to rely on isolated, centralized choke points. A cross-chain bridge is effectively a massive honeypot. It relies on smart contracts holding billions of dollars to back the wrapped tokens circulating elsewhere. Because blockchains produce blocks at different speeds, bridges suffer an asynchronous vulnerability. There's a delay between an event on the first chain and verification on the second. In this limbo, the chains are out of sync, creating a window where verification can be intercepted or manipulated. Attackers have exploited these exact timing gaps and smart contract flaws to drain over $2 billion from bridges in recent years. The current multi-chain architecture is insecure. Patching isolated ecosystems with vulnerable bridges is a failing strategy. Securing cross-chain communication requires a system that doesn't rely on intermediate custodians at all. It requires an application layer that exists everywhere simultaneously. To solve this, we must stop treating blockchains as all-encompassing ecosystems. Instead, view them simply as back-end servers, the hardware components processing and storing data. This is the exact approach of Anoma. Anoma is a distributed operating system designed to sit entirely above these disparate chains. Much like Windows or Mac OS abstracts the physical chips inside your computer, Anoma abstracts the underlying blockchains. It achieves this by deploying protocol adapters to existing networks. These are specialized smart contracts that translate the unique, isolated languages of each chain into one unified format. The application logic moves off the individual chains and into this overarching ecosystem. Here, users no longer sign complex execution paths. They simply sign intents, cryptographic messages declaring exactly what outcome they want, without specifying how the network should achieve it. Now, by separating the application from the underlying execution layer, a developer can deploy their code once and instantly access users and liquidity across any connected blockchain. Now, this introduces a massive technical hurdle. How do you execute an action that requires updating the ledgers of two entirely different blockchains at the exact same moment, without relying on a vulnerable bridge in the middle? Looking at this model of network consensus, Anoma solves this using an on-demand mechanism called a Chimera Chain. The system uses a specific consensus protocol called Typhon. Typhon scans the two independent networks and identifies the node operators that happen to be actively validating blocks on both chains at the same time. Using only those overlapping validators, Typhon spins up a virtual shard, a temporary, highly localized network formed in the void between the two base chains. This temporary network performs an atomic commit. An atomic commit is an operation where a set of distinct changes are treated as a single event that either succeeds completely or fails completely. The cross-chain transaction is executed simultaneously on both sides, entirely eliminating the dangerous asynchronous time delay. Once the transaction succeeds or fails safely without moving any funds, the Chimera chain instantly dissolves. There is no permanent smart contract left behind for a hacker to target. This on-demand sharding guarantees trustless cross-chain coordination. It achieves the exact goal of a bridge while rendering permanent, hackable bridging architecture obsolete. For the end user, the chaotic underlying infrastructure of the blockchain becomes completely invisible. developers will build intent-centric applications that only ask users to declare their desired outcome. The user sets their parameters, signs the intent, and the interface handles the rest. Behind the scenes, the Anoma operating system relies on specialized participants called solvers to find the most efficient route. These solvers match the intents, summon Chimera Chains when necessary, and execute the complex routing entirely in the background. When you open a web browser, you don't care if your computer is using an Intel or an AMD processor to render the page. In this new architecture, users won't need to care which specific blockchain is executing their trade. The era of isolated ecosystems and fragmented liquidity is highly inefficient. The next phase of decentralized coordination relies on a unified logic layer that lives above the chains, connecting the digital economy seamlessly.